I hope my screen is visible.
Yes, ma'am, it is visible.
Yeah, okay. Is that in the presentation mode?
Yes, ma'am.
Yes,
Oh,
ma'am.
good. All right. So, yeah. So this session probably we will see what is the basic infrastructure, IT infrastructure, and we will have an understanding on what is data center, what is network, the entire infrastructure where your server storage is built in, and how it is getting moved to production, how this production server works. Okay, so this is as I have designed only for the beginners, and I'll give you the real examples, like because I have built the data centers and made it to move to live production. So probably that experience I can share with you. Yeah. So before I move on, what is your understanding on IT infrastructure and data center? Probably we'll go with that first before I move on to the basic stuff. You both can tell what is your understanding on this IT infrastructure.
How things work under information technology.
Okay.
Um,
Do you know there is something called data center where the technology and the server storage all hosted over there, and that's how it gets operated.
yes, ma'am.
Have you ever seen how data center looks?
No, ma'am, we never seen. I know some.
Vignesh, what is your opinion about IT infrastructure or data center networking?
And the whole company is set up for hardware, software, servers, networks.
Okay. Okay, fine. So I'll give the basic session, then probably I'll ask the same question at the end of the session too. Okay. So let's understand more about what is data center, what is infrastructure, and why it is required for the corporate to be in um, IT infrastructure or data center. Okay. So data center is like it's a facility that hosts the IT system which runs 24/7. Okay. If in case we have any issues in the data center, like a power issue or any other problem, then of course, it works, it has a backup of getting the power from generators, but still if there is a fluctuation, if the server gets rebooted, then of course whatever the application hosted in that server goes unavailable. It is very critical for the corporates like banking and payment sectors, because they can't afford to have the application down because they will have a financial impact. And not only financial impact, of course, it will be a reputation impact too. So any application that is supposed to run 24/7, so there should not be any outage in the data center, or there should be a backup set in the data center so that the application does not goes down at all. So this facility, the data center, is a facility that hosts the IT system and runs 24/7. This data center is physically located, and where it has got all the, of course, it will need to have a place and a rack need to be set, and a power has to be given to the racks where we are going to host the servers, storage, network, and a cooling support should be there, because when we work on the laptop, if your laptop is continuously working for more than some 4 hours or 5 hours, of course, it will be releasing so much of heat. And if a continuous heat is being released, it will get heated. And if in case it gets continuously heated, of course, the laptop will get rebooted or it will get shut down, right? So because it has to be maintained in a such temperature for the server to get cooled down. So that is the main reason they used to say, do not put your laptop on the bed. Like it has to be in the plain surface. And, mostly all IT companies you could see, it will have the AC air cooling conditioner. So that the heat emitted from the laptop will get absorbed. Okay, it if that is the case for the laptop, think about the bigger servers. A server will be very huge and it is hosted in the data center, and it is not one single server or storage, it is multiple servers and storage, and it requires so much of power for the network, for the firewall, everything to work. So that's the main reason the data center should have a cooling system, so that all the server and storage, all the devices as well as hosted in the data center maintain its own temperature. Okay, and it works in a proper condition. So data center facilities, this IT infrastructure facilities is used by a lot of corporates and the sectors like banks, of course, banks payments works 24/7, hospitals, IT companies, and cloud providers. Cloud, right, who provides the cloud supporting, for example, Google, Microsoft, all it has to be 24/7. So even other applications can be, probably they can have a scheduled downtime and it can go down, but these things like will not go for a scheduled downtime to it should have a high availability. If primary is not working, of course they will switch on to the secondary, or even if primary secondary both goes down, they will have DR, the disaster recovery side. So of course the application has to be available 24/7 without any disruption. That's the main purpose of having this data center operational 24/7. So now we have data center. Data center is all about the space, the rack. Okay, there are different shapes of rack, 600 into 1200 dimension, inches dimension, and you have 800 into 1000. So there are different dimensions for installing the different devices. The network devices will be bigger in size, so you need 800 into 1200 or 1000, and the server and storage devices will be little shortened. The main reason for network devices to be installed in 800 into 1200, it will have a lot of cables in it, in the sideways, in the front, rear, and all. So so that's the main reason. And for the storage and server, it can be installed in 600 into 1200, one tile size. Okay, 600 into 1200 is one tile size, so it can be hosted over there. And the rack size, I was telling about the width, which is like 600 into, the dimension is 600 into 1200 centimeters, whereas the height will be in inches. It is like almost few will be 48 inches, 45 inches, or 50 inches. It is called as like units. One unit is approximately, for example, you can take it like 1 or 2 inches. Okay, so it is called like 50. I have seen 50 units as the tallest rack in India and Australia. So that is the latest height of the rack that we have got. Moving on. So for now we have a space. Now we have a rack. And we have a power. This most of the data center gives only the space, the rack, and the power. So, but what you are going to host in which server, which application is going to run in that server, everything, it is depends on the clients. For example, I'm taking I myself as a company, okay, a banking sector. I wanted to host my banking server in the data center. So banking, for me to operate as a banking, I need to have multiple applications. For example, retail banking, corporate banking, the current account, savings account. So many accounts are involved, and it's a local transactions, international transactions. So many transactions has to happen, and it has to be the wallet transaction. It has to be 24/7. So in that case, I wanted some basic server where the OS is installed, and that server should be linked to a storage where I can save the customer data, the transaction data, all the core banking data in the storage. And from storage, it needs to have a connectivity where you can put in give an API request, and it has to get an API response back. Okay, and moreover, if it is a banking, payment related, or any secured stuff, you need to have a better network. One is internet to give the connectivity to fetch the data or to give the data. Another one is a restriction, the firewall. Okay, firewall has to restrict. It has to check whether it is an authorized API. It's like a gate. It checks each and every API, and it allows inside the network. Do you recollect what kind of an server connectivity that we have seen earlier when I was taking the payment session? Do you recollect what is the data flow I told? Anybody? I said from user, the API request comes in from user and hits first which server? I told something, a proxy server. What server is that?
You said it will hit the backend one, and then some what Nginx something.
Nginx, exactly. The Nginx is the reverse proxy and a load balancing server. Okay, right word. So Nginx will be the first server to hit any API to hit the Nginx. So it will have internal, I mean, we will be having an internal Nginx and the external Nginx. Any API that comes directly from the internet will hit the external Nginx. Any API calling that comes from an organization, right? If I'm a bank, any API comes from the bank network that comes through an internal Nginx. Okay, so that's the first gateway. So from there, when it hits to the respective web server or application server, and then it goes to the database, then the response comes back. It's all the APIs will be bidirectional, so it sends the data as well, it receives the data. So that's why the link is a bidirectional one. So network plays a major role. If there is no connectivity between these devices, if there is no network connectivity, it cannot send data or it cannot receive data. The API calling itself will not happening, right? So network is a core thing. It has to be there. So every computer that connects with the network, the server, devices, everything has to be connected only with the network. So the IP identify the each devices. So you will have the subnet mask like 10.5.20.255, something like that, right? So through the network IP address, you can understand whether it is in a private IP address or a public IP address. You would have learned that in the college days itself. So the IP address will define what kind of network it is, or the segments will be given for if a fintech organization is giving a network IP address for multiple clients, they categorize the client based on the IP address segments. So for example, 10 is the first number, then the next number, 5, 6 or something, that will be the segment given for each client if it is in a shared domain. So you can learn more about how the IP address is done, when we learn more about the networking layers. There are 7 networking layers are there. So when we learn that, we can probably see what are all the segments, how this IP address is allocated to each and every client and other stuff. So this IP address helps us to identify each device. Okay, every device hosted in data center, it could be a network device by itself or server or storage, will definitely have an IP address. without the IP address and the service tag number, which is called, even your laptop or a monitor will have a service tag number, right? So without that, they cannot understand which device is that. So each and every device will be allocated with an IP address if it is connected on the network, and it will be having the service tag number, the device make and model and a service tag number, so that the engineer in the data center will only understand if the service tag number is given. Even if you give the IP address, the engineer will not have the repository to check and highlight if this is the device. So it will be restricted. The IP address details all will be restricted for the data center engineer. Only the service tag number, the make and model will be given to the data center engineer if there is a hard reboot or anything has to be done. So the IP address identify each device hosted in the track, the switch that connects devices in the same network. That is called switch. That will be switch, router, and firewall, right? So a switch is something that connects the devices, all the devices in the same network. A router is something that is connected to the internet, okay, from switch to router. A firewall is something that provides a security. As I said, all API goes only through the firewall. The firewall will tell this is a restricted API, this is an unrestricted API. Restricted API will not even go inside the next layer, that application or web layer at all. So these three are very important in the network side, so switch, router, and firewall. Without these three, none of the server or storage will work, or it will not receive any API, or API will not be responded. So these are the basic things, essential things. It has to be there in the network side in order to make this server or storage or the entire system to work. Okay, that's on the network side. So the network connects the servers, computers, and devices. Each devices will have IP address. The IP address allocation is done by the network, and then the network need to have the switch, router, and firewall. Switch connects the devices in the same network, router connects to the internet, and firewall provides the security. These are the basic things we need to know. This is essential. Even when you go to any kind of interview, the first question they would ask is how the network connectivity is done, how it is connected to the computer or servers or devices. So you need to definitely talk about switch, router, and firewall, which is a basic thing. Clear? Can I move on?
Yes, ma'am.
Okay. So moving on, the next one is infrastructure. Infrastructure is everything, where you have the server, storage, everything comes under, even the network, the database, everything, security, everything comes under infrastructure basics. But more, when we say the infrastructure, we talk more about the server and storages. Okay, so the infrastructure is the foundation of IT system. If there is, for the IT, the information technology, if there is no infrastructure, the IT doesn't work at all, right? So the IT system works only on the infrastructure that has been provided, which covers server, storage, network, backup, and security. So server, which has the OS in it, the storage, if in case you wanted to store any data from server, it goes to the storage. Storage, we have multiple stuff like database and other stuff. And then, of course, for those both to work, you need to have network connectivity and backup. Backup is essential if in case, if there is a compliance issues is there, your data which is there in the storage, the immediate server which is connected with storage, if that data has to be backed up, it has to be copied to one external device, and it has to be procured somewhere. But most of the banking payment side, it is mandatory. The RBI has mandated to secure the data of the customer or the daily transaction for almost 11 years, 10 years, 11 years, 13 years also. So whenever, I mean, all the financial year, right, it starts from April to March. And if in case, if they wanted to take for any purpose, it could be for police compliance purpose or to do some kind of an auditing purpose. If they wanted to see a customer information, for past 5 years or 7 years, it will not be readily available in your local database or local server. Maximum nowadays, if in case you log into the retail banking, when you try to take your statement, okay, hardly you can take 90 days of statement, right? They doesn't allow more than that, which is readily available. And if in case you wanted more than 90 days of statement, I think for few banks has got only 30 days of statement. Whatever the transaction you did for past 30 days or 60 days is readily available in your statement, which is like your internet banking. If you wanted to know beyond that, probably you will have to raise a request and wait. So 1 year data will be immediately available in their local storage. More than 1 year data, it has to be archived. So they copy that in an external hard disk and they just keep it in the archival system repositories. Okay, so if in case you wanted some data of 2 years back or 3 years back, it takes a long time for the bank to give. The reason is they have to go back to the place where they have saved that record. Okay, they have to bring it back. It will be in a decrypted mode. It will be in encrypted mode. They have to decrypt it, copy that, save it in their local server, and then they have to read it, copy it, and give it to you. So it takes a long time for them to take that. So it depends on each institution. It depends on each bank. A few banks, if they could afford, they will try to have it for 2 years to 5 years data in their local server itself, which is readily fetchable. Okay? But few banks, they feel like it is very expensive, so they don't want to store the previous year data because it will be in crores, right? It will be like in millions and billions. So they cannot afford to have so much of data in the local network when they have to pay for it. It is economically, it is not a good solution. So that's the reason they just copy it and save it somewhere. And of course, they will have multiple copies so that one goes off, another one will be there. And it is an audit mandate. They need to have at least 10 years of data copied in the hard disk and kept secured. It should be in an encrypted format. It's one of the basic audit requirement of RBI. So this infrastructure, as I said, it includes the server, storage, network, the backup where you have saved all your data in that, and the security, which is like decryption, encryption, and other stuff. And ensure system runs smoothly and reliably. There should not be any interruption at all. That is the basics of this infrastructure. Okay, is infrastructure okay? Can I move on?
Yes, ma'am.
Moving on, what is a server? Okay. Server is a powerful computer. See, the laptop that you use is also a server, but that's a local server. Okay. If in case you keep it somewhere in a distance place and you give a connectivity to your house network and that server, that is called like data center, the computing, right? And if it is in a massive, it has to be there in the data center. If it is very less, you can see small enterprises offices will have their data center in their office premises itself, because hardly they will have 10 servers or 10 storage devices, where they don't have to go for an cloud computing or a data center because it's expensive for them, right? So they will have their own data center, 2 racks will be put in, and they will have their network connectivity within the premises itself. They will dedicate one space for that. Probably I will take your college itself as an example. College will not have your data center tied up with any other outside data centers, right? It will have a small data center built in your own college premises where your faculties will be connected. It will be a local area network. They will be connected. They will have a shared drive where they can put all their documents, secure all their documents in it. So that is a small data center which is on-prem. On-prem in the sense it is inside your premises itself. Like if in case it has to be built outside, and if the data is huge and like billions and trillions, it has to be kept somewhere out, then you go for the data center. And most of the people, if they are not in the banking side or payment side, they will go for a cloud-based computing also, if there is no threat on the confidentiality of the data. Okay. So The server is, as I said, it's a powerful computer that runs application and services. Okay, types like physical, virtual, and cloud. Physical is something, as I said, like in your premises itself, you will have that on-prem, that is physical. Virtual is you will be working, your office working location will be in one place, whereas your servers will be located in a different place. That is virtual. Cloud is on cloud. You will not even know where the data center is located. It can be in US, UK, somewhere. It will be routing you to a different directions, but you won't even know. But even for a cloud, it is not something like you don't even know where it is built. It will be there. Of course, it requires a physical data center with a vast storage, but it all will be shared. Okay, so when you go to the data center, there will be a rack hosted, and you will have your bank or your office server storage in one rack. Okay, that is called as a dedicated rack or a dedicated environment. But whereas in the cloud computing, right, you will not even have any idea whose device will be placed on which rack and all. So that you will not have any idea about it, how it is hosted in those rack, what all the other clients are there. But everything will be secured as per the compliance level. Okay, so that is cloud, where we will not have any idea where it is hosted and how it is running. But still, you will know through the IP address and other things. If you have a proper monitoring channel and stuff, you can know where this API goes, and through which you will come to know whether the requests are coming in from which location, whether it is coming from UK or US or Singapore, where it is. It can have multiple HAs, that is nodes. Nodes are called the high availabilities. So the types, as I said, physical, virtual, and cloud. These are the types of servers we will have. Example, banking or hospital application server. So banking server, and most of the time it is like, you will not know where those servers are located. It will be either in the virtual data center, or it will be hosted in the cloud data center. Mostly the banking will not have a physical data center. Okay, because of the data confidentiality and theft issues, they will not be having a physical one. There is a small office where they have a limited data to be secured. They will have on the on-prem itself. So those are the three types of servers. Moving on, storage. Server is there, OS is hosted. So what are the types of OS we have?
In what, ma'am? In mobile?
Mobile. See, mobile is a different gadget. Server is a different gadget, but OS all very similar. Okay. So Windows is one of the OS.
Yes, ma'am. iOS, Mac.
Linux,
Yes, ma'am.
Unix.
Mm.
And we have a legacy thing called AIX, which we spoke during the last session, right? Where the AIS mainly runs for the mainframe application. And it's a very old one, but very it has got a lot of secured stuff. Most of the other country IT prefers mainframe, so they still feel it is a very secured environment. Your card transaction like AS400 and a lot of card companies still hosted in mainframe. Okay, and slowly they are getting migrated from AIX. They are moving to Linux because the support for AIX is getting ended, right? So, but still, we still have AIX as an OS. It is still running for mainframe application, especially. Otherwise, most of them has been migrated to Windows and Linux. So those are the OS we have got for the servers. Okay. Then so those are the servers, and the storages. Any data, you will have a very limited space in your laptop. If you consider laptop as a server, you will have a very limited space. If you're just trying to dump in a lot of files in your laptop, then of course it will not have space, because 80% of the space will be occupied by your OS itself, right? So what you do, you just try to get a hard disk. So that hard disk is a type of a storage. External hard disk. You will have an internal disk also. Disk storage will be there, and then you can also get an external hard disk drive HDD. Okay, and then you have different types of storage. That is SAN switch. We used to say is like SAN switch device and SAN NAS. The expansions you could see. Probably you can just try to Google it or ask ChatGPT. And the cloud storage. Cloud storage is something, it is not in your hand. You will not even know where it is getting stored. It's on cloud. So then, what are all the types of files that is getting stored? Is like you will have pictures, images, documents. It is getting saved as a files, database, backups, and the user data. Backups, as I said, if you just instantly save it in your server, that will be saved in a file format, and the database will also be connected to your server. But if in case you wanted that data to be stored in another external hard disk and secured somewhere, that comes under backup. You take a backup, store it in an external data, and you keep it aside for future use. And then the user data. So these are the datas that will be stored in the storage. User data is like if you get into any organization and institution, or even for bank also, the bank employees data or the clients the bank has got, all those user data will be saved in the storage. So that is the user data. And the people who works for that institution, they will also have some kind of data secured in the shared drive, right? So that is called user data. Clear? Shall we move on?
Yes, ma'am.
Yes, ma'am.
And then any question?
No, ma'am. Ma'am, the storage comes under cloud also, no, ma'am?
Yes. Cloud
Okay.
storage, HDD, SSD, SAN, NAS, and cloud.
Okay.
Okay. Our Google Workspace, that's a cloud, right? The Gmail that you use, that's a cloud. You don't even know where the data is getting saved, right? You don't know where the data center is hosted, where it is. So they will just give you 15 GB is the limit. You use that 15 GB, you can have any kind of files. It could be media file, it could be in the form of any extension, PNG or JPG or PNP or PDF or doc, or it could be any type of files. It's all called as files, right? Any type of file where they give a cloud storage space. For example, for the Gmail, they give 15 GB as a free. And if in case you want to move ahead, you have to go for a paid version. But this cloud storage, you will not have any traces where your data is getting saved. You can't physically go and see where it is being saved. So that's called the cloud concept. It's completely shared environment. But if in case you run an office, okay, and you buy a server, you host a server, and you buy an external hard disk, you are trying to build a local area network. And if you have small employees like 10, 50, 100 employees, and you wanted all the data to be connected in one storage, so then it is a in on-prem premises data center solution, which is like physical. We saw that physical, virtual, and cloud, right? So it comes under physical, and all your data will be saved to it. So they try to buy like this much 10 terabytes, 50 terabytes of storage device, and they try to procure in their data center, so that all the people who works for that institution, they will have all their files and data stored in that database. So that is an on-prem, that is physical storage. Apart from that, you use pen drive, etc., etc. Those are the types of storages too. But pen drive nowadays we don't use it much, right? So this floppy disk, everything has gone. Now we are not using this. Even CDs also we are not using of late, right? So we just directly go to a hard disk. Because that's economical now. Anybody can just go and buy one TB hard disk, and they can try to The CCTV footages, if you could see, if you would have installed CCTV, probably they will ask you to buy a 50 GB or a 1 TB hard disk, and it will be connected to the CCTV server, and it tries to copy all the footages, and it gets copied in that. So of course you can see, probably try to see like 6 months or 1 year of CCTV footage in that hard disk. Sometimes you could see people, those who go for theft or something, they remove that hard disk and they take it off. So those things, like, you cannot, if it is not being synced with cloud, you cannot take the footage at all. So these everything is a server connectivity stuff only, but all that is in a day in, day out life, you have to see even right from the mobile that you use, right from the CCTV footage or anything that is connected to the network, you have to try to categorize and see whether it comes under LAN, WAN, or whatever it is. Okay, there is no much difference between a big data center. It's because of the big data, it is there in the big data center. If it is a small data, it can be in our mobile itself. Okay, that's the thing. So backup and recovery. So backup is a copy of the important data. Of course, as I said, if it is a banking or payment, they will have to make a copy of it. They decrypt it so that nobody can read it. Later, if they wanted to take it back, they encrypt, copy the data. Okay, so it is because done to prevent the data loss. And the disaster recovers, restore system during the failure. As I said, like primary, secondary, even DR, it's all done. The entire country is a disaster and all your data is copied in that country only. Then of course, if in case you have copied some data in a hard disk and kept it somewhere where the disaster doesn't happen, then you can bring that data copy back, put it in the system and make the system to run immediately. So that is the main reason to have the DR, which restores your system during the failure. Okay. So that's the backup and recovery. Production environment. So the production is the live environment used by the real users. Okay. So the other environment that we have is development. We have dev environment. We have testing environment. So after the dev and testing also, we have one another kind of environment is pre-prod. As I said, like developers, mostly they are not connected with the real-time production servers. They will not do a mirroring and all. They will have an isolated server where they do all the testings, and they feel like if they feel it is comfortable, it is working fine, then they will move to production. But even before moving it to the production, few banking payment sectors will have pre-prod. So they just wanted to see if it moves to the production, how does it work? That is called pre-prod. If it works perfectly in the pre-prod, then they move it to the production. That is another kind of layer they have it in order to ensure there is no errors. Okay. So then it requires high security, of course, and requires a monitoring and requires a minimum downtime. If a production server goes down, immediately we will come to know if a monitoring is enabled. Okay, so the monitoring will be enabled for any API or for the infrastructure in the Nginx layer itself. So Nginx it sends the API next to the application server or a web server, and then it goes to the database server, then it comes back, right? So all API request versus response all goes through Nginx and comes back through Nginx to the user. So in that case, the monitoring will be enabled in the Nginx layer itself. So even if in case the firewall is restricting the API through Nginx, you will come to know. So most of the high-level servers, the databases issues, the network connectivity issues, everything will be get monitored in the Nginx layer itself and through the monitoring team, the monitoring tools. So there are a lot of monitoring tools available in order to monitor your server and application. Application side, you have Elastic, Logstash, Kibana, that is the latest one, which I also have worked on, have got a hands-on experience. And for infrastructure monitoring, infrastructure is whether your server is responding, your server is initiating an API call with your database, or the database, sorry, to that from application to database, whether the API call is getting initiated or not. So all those monitoring will be done through these Elastic Logstash Kibana, that is the API monitoring tool. And if in case the physical devices, whether it itself is working fine or not, whether your server CPU is high, or your storage is high, because of that the application is not performing well, or it is not establishing a connectivity between your database, or the server has went to the idle state, or it got restarted, or if in case the server network connectivity itself is not there. So all those infra monitoring will be done by a few set of tools, like the currently what is available is Zabbix. We have Splunk. Lot of infra monitoring tools there to monitor your physical server, storage, database, and API monitoring, which is like from application level, if whether the application is performing fine or not, those API callings will be monitored by a different tool. Splunk also does to an extent, but we have other API monitoring tool, like as I said, ELK, Elastic, Logstash, Kibana, and few other tools as well. So I'm keeping it very basic. The reason is, if you wanted to study more on that, I can still help you with, I can detail you on that monitoring dashboard, or the other API monitoring tool, or infra monitoring tool. If I say this now, it is going to be too much high for you. So I'm keeping it very low. Okay. And you need to have a lot of hands-on experience in order to check that. So that if we have this kind of monitoring system enabled, security system enabled, we can have a very minimal downtime on the performance of any applications. Okay. And application flow, user sends requests through the internet. Of course, any request that comes in from end user, it will be only through the internet. It hits the Nginx file, then from Nginx firewall will check the security level, and then server processes the request. So API goes further from application server to the database server. So database, it stores and it gets the response, it retrieves the data. It goes to your database where your particular information is stored. It will check, validate, it takes some response, and then it goes back to the respective application server or HTTP server, and then the response is sent back through the firewall, through the Nginx, and through the user, sent back to the user. That's how the application flow works. This we saw in the previous sessions, which we took for the WhatsApp and for the payment APIs, right? It's just similar stuff. And in order to see this, as I said, monitoring in production is really required. The reason is monitoring ensures the system health, whether the system is available, whether it is uptime, or if system goes down, then it captures the downtime. It tracks the CPU, memory, disk, network, application. Wherever there is some interruption is there, the monitoring system captures that, and it sends an event or alert to the respective team, so that immediately the team can come into the thing. When we saw the ITIL, I spoke about the incident management team, right? So the monitoring team, the reports to the incident management team. The incident management team mobilizes a call with all the team, the network team, the application team, the database team. All team will come to a call, and they will see where the issue is, in which layer the problem is, whether the network connectivity itself is not there, but the network connectivity is there, maybe because of the server CPU is high or database CPU is high. Because of that, the application is not talking with the database, or the application itself is having some module level problem, and because of that, the volume is not coming in. So there could be multiple reasons for the application for not to perform. So these incident management team mobilizes the call with the respective teams in order to narrow down where the issue is, so that it will get sorted. Okay, as I said, the common tools that is used is Nagios, SolarWinds, Dynatrace. I forgot to say about that. Dynatrace and Splunk. These are the common tools which is used to capture all level of failures. Could be network side, database side, server storage side, or in the application side. Okay, clear?
Yes, ma'am.
Yes, ma'am.
So roles in IT infrastructure, the infrastructure engineer manages the server and the hardware. Okay, on the console level also they manage it, and on the hardware level also they manage it. The network engineer handles both connectivity and the firewall. The application support monitors the application health, and as I said, like application is getting too many traffic, whether it is sending the right traffic to the database and whether it is getting the right response from the database. So those all will be checked by the application support. The database administrator, DB administrator, manages the database, and the monitoring team handles the alerts and the uptime. Whenever anything goes down, so since I was heading the monitoring team, I can say whenever anything goes down, the first team to highlight is the monitoring team, because they will get the alert first. And then they will know whether it is an infra related alert, OS related alert. If it is a Unix related or Linux related, they will talk with the respective team. Or if it is an application related, they will take it up to the application team. Or if it is a network related, they will take it up with the network team. But if it is a priority issue, the entire system is down, they will immediately report based on the severity level. They will immediately report to the incident management team. The incident manager immediately mobilizes the call. The person will invite everybody over the call, and they will try to bring the system back. There will be some service level agreement, which is called SLA. So within 30 minutes or 15 minutes, the services has to be resumed. So they'll try to give some kind of a workaround and try to resume the system so that the system is back operational. And then the problem management comes in, and they see what could be the root cause, why this went down, what is the issue, where the issue is, infra side, I mean the server side or storage side or the network side or the database side or the application side. They check, they analyze, and they try to bring in a preventive action so that it doesn't recur in the future. So those team does all those things. The monitoring team handles the alerts and the uptime. All right. So this is on the roles on the IT infrastructure. If in case you're being in a IT SM team, service management team. So these are the teams comes under, these are the roles and responsibilities, and these are the server devices, everything that you're supposed to know if in case you're gonna work in ITSM, that is IT service management field. That's about IT infrastructure. Okay, questions?
Yes, ma'am.
You need to ask questions.
Ma'am, is it the same for every other sector also?
Everything, each and everything, it is the same thing. It's all about you need to know where their data is hosted. Is it in a physical data center, or it is a virtual data center, or it is in the cloud computing? That's all. But the basic is this: how you say A to Z, the alphabets will not change, only the grammars and other things will change. So it's a basic thing. Everywhere it is the same thing. These are the basics and nothing beyond this. Based on this, you will have more. In the security level, a lot of things comes in. Compliance level, they will have another server added to the Nginx, the security team, in order to do a lot of auditing. So yearly ones to answer the compliance, to keep everything under compliance, they will do further more auditing. So these are the basics. I didn't get into the technical level of whether it is a Tomcat server or what kind of server and all that. You will get to know when you start to work on it. But basically, you should know these are the connectivity, these are the things has to be there in order for the server to run in a production. Okay. Any other questions?
As you said, servers and this production and all should be managed by manpower, ma'am.
It's an automated, right? Once you host it, for example, you install a CCTV, right? So you install it and you know everything is runs well. All your data is getting captured in that hard disk where you have built in it. Only if in case while monitoring that CCTV footage, when you come to know that it's like poor network or something is not showing up, the visualization is not showing up, then you will come to know there is an issue. You go, you check that. Until that, you don't need a manual support over there. So that kind of again, you can enable an alerting if in case network goes down, or if in case all of a sudden the power gets switched off or something. You can enable a alert to your mobile or something. It's so similar to that. Even for server storage and databases, you can enable alerts using these tools which we saw. So you will get to know.
Okay.
Not necessarily all the time there should be a manpower enabled in order to check that. Everything is automated.
Okay.
Any other questions?
How much does it cost to implement a server?
Depends on the storage size, okay? So